Hello students, how are you? I hope you are doing well. In this video, I have come up with three questions. Two are from optics and one is from surface tension. So let us discuss them one by one. The first question is light rays from an object have been reflected towards an observer from a standard flat mirror. The image observed by the observer are. The properties of the image observed by the observer, okay? Not the image. The properties of image. Now, this is a very simple question. This is a plane mirror. Okay, you have an object there. Light rays are reflected from the plane mirror, and they enter the observer's eye. That's all. So when they get reflected, they appear to come from a point like this. Okay. So the observer sees this. So this is the image. So as you know, image is not real; it is virtual. So A option A is wrong. It is erect. You know, plane mirrors always form an erect image, isn't it? You stand in front of a mirror, you can see your erect image. Then plane mirror always forms the image of size equal to that of the object. So therefore, smaller in size means this is also wrong. And plane mirror forms an image which is laterally inverted. Laterally inverted means what? The left of the object is the right of the image and vice versa. For example, when you wave your right hand, your image, you could see that the left hand is being waved. When you wave your right hand, in the image, you can observe your left hand being waved. So that's lateral inversion. This is also correct. So B and D are correct. So correct option is first option, B and D only. B and D only. Is it okay? Then let us move to the next question. Question 15. An object is placed on the principal axis of a convex lens of focal length 10 cm. As shown, a plane mirror is placed on the other side of the lens at a distance of 20 cm. The image produced by the plane mirror is 5 cm inside the mirror. 5 cm inside the mirror. So that means the final image is here at a distance of 5 centimeters here. You know, object distance and image distance are always equal in case of a plane mirror. So the object corresponding to the plane mirror, and take it as O dash. The object corresponding to the plane mirror must be 5 centimeter in front of the mirror. So what is this object? This is nothing but the image due to the lens. Okay. So this is O, the object. So light ray starting from the object must form a real image here. So O dash is the image corresponding to the lens, but it behaves as an object for the mirror. So this distance, I'll take it as x. So this distance is 20 minus 15, that is 15 cm. So 20 minus 5, that is 15 cm. And focal length of the lens is given as 10 cm. Okay. So using lens equation, we can write 1 by v minus 1 by u is equal to 1 by f. So 1 upon minus x, sorry, 1 by, image distance is plus 15. So 1 by plus 15 and u is minus x is equal to 1 by 10. So 1 by x will be 1 by 10 minus 1 by 15. You can take the LCM if you want as this way, or you can solve it this way. The way I am solving, you can take 5 common in the denominator. So we have 1 by 5 into 1 by 6. So x is equal to 30 cm. So 30 cm is the answer. 30 centimeter is the answer. Moving on to the next question. A spherical drop of liquid splits into 1000 identical spherical drops. If Ui is the surface energy of the original drop and Uf is the total surface energy of the resulting drops, then Uf by U. Now students, surface energy, what is it? It is nothing but the excess energy possessed by all the molecules of a liquid which reside on the surface. Okay. As compared to the molecules which are well within the liquid, all the molecules which is residing on the surface, they have additional energy. Okay, because when they come from inside to the surface, they have to do work against the attractive forces. All the inside molecules tend to attract them. So by doing work against them, they reach the surface. So in that way, they carry additional potential energy on them, which is known as surface energy. And this surface energy per unit area is equal to surface tension. Surface energy per unit area is equal to surface tension. So surface tension is constant. So we can write that the surface energy is proportional to area. Surface energy is proportional to area. So here, a spherical drop of liquid splits into 1000 identical drops. So this is a original drop, and this splits up into several identical, means similar 1000 droplets. Let us say radius of the original sphere is r, and radius of each droplet is smaller. So basically, the ratio of surface energy will be equal to the ratio of the surface areas, and surface areas are proportional to r square, because surface area of a sphere is 4 pi r square. So I write this as 4 pi r square. So surface energy is basically proportional to the square of the radius. Now coming to the final question, you have UF upon UI will be equal to, UF means final. Final means for each sphere it is r square. So for 1000 spheres it will be 1000 into r square. For UI you have only r square. Remember I have cancelled 4 pi. Okay, if you want you can write this. This is for each sphere. I'll write the final. Okay. Now what is the relationship between the two radii? You can conserve the volume of the liquid. The amount of liquid remains same. So conserving the volume of the liquid, you have 4 by 3 pi r cube is equal to volume of one droplet multiplied by the number of droplets. So extracting the cube root, you have this. So small r, you can replace small r by r by 10, or capital R can be replaced by 10 small r. Anyway is okay. So this is 10 power 3, small r, keep it as small r, capital R you can write it as 10 capital R, 10 small r, sorry. So you have 10. So the value of x is 1. You are getting the ratio as 10, and they have been given as 10 by x. So 10 can be written as 10 by 1. So 1 is the answer. So I hope you liked my video. Keep preparing for JEE mains, and all the best. Okay. Thank you so much.